All right, today we're breaking down a really fascinating new framework called MACRO-LLM. It's all about teaching teams of AI agents how to work together, even when things get really, really messy.
So let's just jump right into the core problem here. Picture this. You've got a team of AI agents, right? But here's the catch. None of them can see the whole board. They each have just a tiny piece of the puzzle. So how in the world do you get them to team up and actually succeed?
Okay, let's dig into what this challenge really looks like. The paper calls it spatiotemporal partial observability, which is a mouthful, I know. But the idea behind it is actually super intuitive.
I mean, think about it. A fleet of self-driving cars on the freeway or a swarm of drones responding to an earthquake, they can't possibly see everything everywhere all at the same time. Their world is limited by their sensors, their cameras, and their communication range.
And this graphic just nails the concept. It's like every single agent is wearing blinders. Spatially, they only see what's right in front of them. And temporally, well, the future is always a bit fuzzy, a big question mark. And you can guess what happens next. When each agent is just acting on its own tiny sliver of information, you get chaos. One car slams on the brakes while another one tries to speed up. It's a recipe for confusion, conflicting moves, and, well, total mission failure.
So how do you fix a problem like that? Well, that brings us to the solution the researchers came up with, this framework they call MACRO-LLM.
The big idea here is that MACRO-LLM is decentralized. There's no single boss AI calling all the shots. Instead, it gives each and every agent the tools it needs to talk it out, to negotiate, to solve conflicts, and to learn from what happens all by itself.
And what's so cool is where they got the inspiration from? Us. From human teams. I mean, think about it. We almost never have the complete picture, but we manage to get things done by talking, by compromising, and by adapting. MACRO-LLM tries to give AI those very same skills.
So, how does it actually work under the hood? Well, the framework basically gives every agent what I like to think of as 3 teamwork superpowers.
See, inside every agent, you've got this architecture with 3 main parts, or modules, that are constantly working together. And as you can see in this diagram, they're not just separate tools, they're synergistic. Each one makes the others even better. And to make this really easy to remember, let's give them job titles. You've got the CoProposer, that's the strategist. Then there's the Negotiator, the team's diplomat. And last but not least, the Introspector, that's the analyst.
Okay, first up, the CoProposer, our strategist. This module is all about thinking ahead. Before an agent does anything, the CoProposer comes up with a plan and then runs a little simulation. The paper calls it a rollout, to see what might happen. It's like a quick mental test drive to make sure the plan is safe and won't cause a disaster.
Next, you have the Negotiator, the diplomat. This is the one that steps in when agents have different ideas about what to do next. But here's the genius part. Instead of having them all shout every little detail at each other, the Negotiator has them share quick, high-level summaries. It's way more efficient.
The fancy technical term for this is mean field approximation, but this analogy is just perfect. It's like getting the general vibe of a crowded room without having to stop and talk to every single person. It's a super smart shortcut to get everyone on the same page.
And finally, we have the inspector, the analyst. This module's job happens after an action is taken. It looks back and asks, okay, did that go the way we thought it would? It learns from what worked and what didn't, making the agent smarter and better for the next time around. This is the key to adaptation.
So a clever framework on paper is one thing, but does this thing actually work? Well, let's see how MACRO-LLM did when they put it through some seriously tough tests. The researchers set up 2 very different, very difficult scenarios. First, they had a fleet of cars that needed to drive in a tight, perfect formation, a task called cooperative cruise control. And second, they ran a pandemic simulation where different agents had to work together to stop a virus from spreading through a city. And the results? Well, the numbers speak for themselves. Look at platoon stability. Lower is better here. The best of the other methods scored a 0.994. MACRO-LML, 0.455. That's more than twice as good. Same story for precision. It's just a clear, decisive win.
And this chart shows you exactly what those numbers mean. Look how smooth and stable the lines are for the MACRO-LLM agents. They hit a bump, sure, but they recovered together smoothly. The other methods, you see those wild, jagged lines? That's chaos. It's inefficient, and frankly, it's unsafe.
But if you thought that was impressive, get this. In the pandemic simulation, the baseline method took 95 days to get the virus under control. MACRO-LLM's team of agents did it in just 33 days. That's not just a little better, it's almost 3 times faster. A total game changer.
But here's the ultimate proof, the real kicker. The researchers asked, what happens if we take away one of the superpowers? Well, when they removed the CoProposer, the strategist, the one that looks into the future, the result was a complete catastrophe. The cars just couldn't coordinate. They literally crashed. It proves that every single one of these modules is absolutely critical.
So let's zoom out for a second. What's the big picture here? Why does creating a framework like this matter so much?
Let's just boil it down. First, this shows us that AI teams can pull off incredibly complex tasks without needing a central boss. Second, it proves that thinking ahead, simulating the future, isn't a luxury, it's absolutely essential for safety. Third, it gives us a model for smart, efficient negotiation that can scale up to huge teams. And finally, it hammers home that learning from the past is the only way to build AI that can truly adapt.
And that leaves us with a pretty mind-bending question to think about. We've seen this work for cars and for disease control. So if AI can learn to negotiate and team up this well, what's next? Managing our crazy complex power grids? Untangling global supply chains? The possibilities are just massive.